All right, so factor the top. Or does 12 divide into 60? Yeah, 5 times. So if we factored it out, it would be 12 times 5 in the top. And then I'd have x cubed there. And now I have a 12 here times x. So if 12 divided into 60 perfectly without a remainder and we got a 5, you can do that. That's perfectly 100% normal. But the concept of being able to factor this into different factors, because I have 12 is a factor, 5 is a factor, x cubed is a factor. Now I can say, all right, what can I divide out? The 12s can be divided out. And so I would have my 5 in the top. Now I have 3 x's in the top and 1 in the bottom. It's 2 x's in the top, right? So you could have done that. You could have said, all right, it's top heavy by 2, so I'd get an x squared. Or you could have said x to the 3 minus 1, because that's our property. But either way, you're going to get 5x squared as your answer. So I'm adding something to the instructions here where you actually have to simplify but also find the excluded value. So we got our excluded value, x equals 0, because that doesn't work now. But we're also be able to factor down to 5x squared. Because if this was our original function, we could graph 5x squared, but then worry about, hey, when x is 0, 0, 0 is going to have what in it? Is it going to be a whole or an asymptote? Could I divide it out or could I keep it? Well, that x, did I keep that x or did I divide it out? I divided it out. So if I divide it out, it's a whole. The bottom, when you're looking for values that are going to make this undefined, it's always going to be the denominator, the bottom, equal to 0. And you're going to want to check after you factor. Like for this guy, the next one, number 3 here, can I factor the top? No. So that's just m plus 7. And I put that in parentheses because for some reason people like, if they see an m in the bottom, they like to cross out the m's. But m plus 7 is the factor itself. Now, do I know two numbers that can multiply to get to negative 21 that can add to 4? 7 and negative 3. So I can say m plus 7 and m minus 3. Now, before I even factor anything out, for excluded values, what I'm going to do is I'm going to take the first factor, set it equal to 0. m plus 7 is equal to 0. So what's my m value? Yeah, it's a negative 7. I'm going to take the second one, m minus 3 is equal to 0. So m is equal to 3. So those are my excluded values. So if we graph those, if we graphed this, we'd have a couple different things going on there. Now, any factors I can divide out? M plus 7. So I can divide that out. So let me ask you this. Since the denominator is where we find our wholes and asymptotes, is m plus 7 a whole or an asymptote? A whole. M minus 3, is that an asymptote or a whole? Asymptote. So I could say VA there. And then I could just say the final answer, the m plus 7s are divided out, it's just 1 over m minus 3. And since I'm able to remove the m plus 7s, if I graphed it, it would be m plus 3. Or 1 over m minus 3 would be what I would graph. Knowing that I have a vertical asymptote at -7 and knowing that I have a hole at 3. So I'd have to figure that out in the original functions. So you got to factor. And thankfully, I'll give you a hint on this guy. When you have a negative n squared, change this to -1 times n squared minus 16n plus 63. And that'll be a whole lot easier to factor. You're just going to have that -1 in the top over n squared minus 2n minus 35. And the top. Bottom and the top. The bottom is going to give you excluded values. That bottom is going to give you excluded values. The top is going to help you divide out the different factors and simplify everything. So you have to divide not divide everything. You have to factor everything. Everything needs to get factored.
So we factor them first and then we find the excluded values?
Yep, factoring first, find the excluded values. Like number 8. Nothing to factor in the top. What can I factor in the bottom? 15, and then I'd get a minus 1. Now, if you aren't very good at simplifying fractions like this, you can change it to 3 times 3 and 3 times 5. 3 times 3 is 9, 3 times 5 is 15, and down here I get a minus 1. Well, what's my excluded value? Well, this guy, since it's an a value, since it has a variable in there, that's the only thing that can be equal to 0. Can 3 ever be equal to 0? No. Can 5 ever be equal to 0? No. So I'd say a minus 1 is equal to 0. So if a minus 1 is equal to 0, a is equal to 1. That's my excluded value. Now, what can I divide out? I can divide out that 3 and that 3. What's left over? 3 over 5. And then the a minus 1 is still there. Yes. So I got an excluded value, and I actually was able to simplify the expression down. Now, there's factoring a quadratic. That's factoring number 9. I'll just tell you it's common factor because they're both quadratic, but that's more of a common factor problem than anything. Quadratic over quadratic, so you're going to have to factor quadratics again. But notice what's the number in front of a or in front of the first variable? It's a 1, so these are a little bit easier to factor. But if we jump to the back, all right, let's take a look at this guy. Now, here we go. Two numbers that multiply to get to -15 that add to a -2. Not 3 and 7. Which one's negative, though? 5. So I'm going to get x minus 5, x plus 3. right over yeah, there, perfect. And now in the bottom, two numbers that multiply to get to 5 that add to negative 6. X minus 5 and x minus 1. Alright, so hopefully by sight, what number is going to make x minus 5 equal to 0? Positive 5. So x equals 5 is going to be an excluded value. What's going to make x minus 1 equal 0? X equals 1 is an excluded value. What can I divide out? The x minus 5s, right? So I can get x plus 3 over x minus 1, and that's my final answer. But I also know that it's not going to, the function won't exist here or here. Now, do I have a hole or a vertical asymptote at x minus 5? All right, so I have a hole there. And what about here? That's a vertical asymptote because it's hardwired in and I can't get rid of it. Well, the x plus 3 will tell us where we have an x-intercept. If I set that equal to 0, I know that x, when x is 0, y would be negative 3 over negative 1, or 3 over negative 1, which would be negative 3. So I have a y-intercept at, I can figure out a y-intercept, I can figure out an x-intercept, I could do all that kind of stuff. Now, 15. Right now we're just dividing stuff out. Is this a multiplication problem or a division problem? All right, it's a division problem. And when you start the division problem, you're concerned with that part of it. You're concerned with the dividing sign and then everything afterwards. This is just going to be, I'm going to change the multiplication and I'm going to flip this guy. This is going to be v minus 10 over 1. And I still have all the stuff here. I have v minus 7, v plus 8, v plus 8, v minus 10, and 1. And I'll put the v minus 10 here. Now, the nice thing about multiplication is that once it's in factored form, it's just going to be v minus 7 times v plus 8 times v minus 10 over v plus 8 times v minus 7. So we can start dividing out common factors if it's in multiplication problem. What are my excluded values? What's going to make this first one 0? Negative 8. So what's going to make this one 0? 10. So over here I'll do my excluded values. X equals negative 8, x equals 10, and or v, sorry, since we're dealing with v's. If you can't see that, just say v plus 8 equals 0, subtract your 8, and then you'll get your negative 8. And then just do v minus 10 equals 0. And make sure when you do this you put an equal sign there because this thing is equal to this thing. Now what can I divide out? The v plus 8 and the v plus 8. Anything else I could divide out?
V minus 10.
I could divide out those two guys. What's left over? v minus 7 over 1, which is just equal to v minus 7. So we completely simplified it down to one term only, v minus 7. That's how you end up dividing. I'll zoom out just a little bit. What would I, here, 19 is another division problem. What would I multiply by? Would I multiply by b minus 6 over b plus 5?
B plus 5 over B minus 6.
Yeah, b plus 5 over b minus 6. You flip it. And then you got to factor this guy. I know there's a b plus 5 here, but then you have to factor the top. That'll get you started with that. And one final thing when you're actually factoring, remember what the rules of factoring are. Good madness. Where are you going? I'll take you there.
Excuse me, you're taking it from my hand.
I'm not gonna put it back in your hand.
You can't put it.
No.
I want to say excuse me.
What are you doing up? Alright, so factor out a common factor first. Factor, you might have to factor ax squared plus bx plus c. You might have to do grouping. Difference of squares. A squared minus b squared is equal to what? No. A plus b times a minus b. So if it's like x squared minus 16, what's this going to be equal to? What squared equals 16? 4. So it's x plus 4, x minus 4. Difference of cubes. You might have to do a difference of cubes, but I'm probably not going to do that to you. Difference of what? Yeah, you can, but you don't really want to.
It's for if you take out common factor, and you can for number 19.
Well, yeah, for number 19, up on top here,
You can do b.
and then it'd be b minus 6.
Can we subtract? I mean, when you flip the other one,
Yeah, B minus 6 and B minus
can you take another one?
Well, you have a b minus 6 here and here, so yeah, you can divide those out.
2b.
And then you get the b plus 5s you can divide out. So
left hold to B.
that divides into that divides into that. You're left with 2b.
So that's it.
Well, 2 and 12, common factors of 2. B squared and b, take out the smallest factor. And if the people who were taking the test today turn in their test, I will show you how to graph that one that you guys weren't able to graph. And I'll give you one little big hint.
I told them I know.
I took the common factor, but
It worked.
It was, bro. I told them.
Are you taking a test or are you doing this? So, anybody taking the test? All right.
Just for that one, would you always do reciprocal if it's
For division, yes. Division, you always do the reciprocal. All right.